LeetCode problem number 1046, last stone weight. So this problem gives us an array of integers, stones, where the stone's I is the weight of the stone. Right. Okay, so on each turn, you will choose the heaviest two stones, smash them together, and here you have a scenario, right, where if x is lesser than y, lesser or equals to y, and if x is equals to y, both stones are destroyed. If x is not equals to y, the x stone is destroyed, right? Because in this case, x can only be lighter than y, right? And the stone of weight y has a new weight, which is basically y minus x. Okay, so at the end of the game, there's at most one stone left, right? So we have to do this process repeatedly until we have only one stone left or none, which is case if there are no stones, we just return 0, right? Okay, a fairly straightforward problem. Can be a bit confusing here, but overall it's basically comparing two heavier stones, and if they are not the same, we just take the difference, right? And if they are the same, then we just destroy both of them, right? So knowing that, we have to use a priority queue. So this priority queue will be used to store the weights of the stone in sorted order, right? So when we compare, we can just instantly take the top two heaviest two stones, right? The heaviest two stones. Okay, let's start with some examples. So let's say the stones is this. I'm just gonna use the example given in the example section here. But let's say our stones are so. Okay, and then we put it inside the priority queue. So right now our priority queue will look something like this, right? So we 8, 7, 4, 2, 1, 1. Okay, in sorted order. That's how a priority queue works. Okay, so while the queue size is more than 1, we pop both. We pop the pop two heaviest stone. In this case, x is 8, y is 7. The difference in this case would be the x minus y, and then since the difference is not 0, right, minus y, so this will give us 7, this will give us 1. Since it's not 0, we will push 1 into our priority queue, right? So remember that these two are popped, and then we push 1 in here, right? Then the next loop, again, we take the top two stones, right? Pop these two, compare them, 4 minus 2. In this case, we will get 2. The difference is 2, and since it's not 0, then we push into our priority queue again, right? Like this. Alright, then again, we pop 1 and 2. We pop 2 and 1. The difference now is 1, right? Because 2 minus 1 is 1. The difference is not equal to 0. We push the difference, push 1 into it, and then repeat the process, pop these two, and now the difference becomes 1 minus 1, which is 0. Since it's 0, we don't do anything. We do not need to push 0 into our stones, into our priority queue. And since now the size of our priority queue is not more than 1 anymore, it is 1. So here I have a ternary. Basically, this checks whether or not the priority queue is empty. If it's not empty, I will return it the top of the priority queue, which in this case will be 1, right? So you see here the output is 1. let's say if all stones are smashed, then this will return false, and then this will give us the 0, right? It will return 0 just like how the problem asks. Okay, pretty straightforward, a pretty simple while loop can get this done. That's all I have to share. Thanks.